Hi everyone, welcome to Grafom News webinar. Accelerate your time to market with 3D scanning. My name is Stephanie Benjumea and I'm marketing project leader here at Grafom. I'm really excited to be monitoring today this webinar. I'm here with the two great speakers, Mathieu and Simon. We are going to introduce them very soon. Before getting to the fun part, I would like to mention a couple of things. Many of you are wondering if this webinar is going to be recorded, and the answer is yes. You are going to receive an email shortly, and you have the link to watch the webinar. And also you can go to the Grafon website and go to the resource center and watch the webinar too. So you can see all of webinars that we have made since the beginning. And the last thing, as always, we have a few minutes at the end of the presentation to answer your questions. So you can ask your question at when you want. And so I encourage you to ask your question to the question panel on the right side of your screen. So let's go. To begin.
So before starting the presentation, we would like to first introduce ourselves. So my name is Simon Cote. I'm in charge of product management at Creaform and have been working in 3D scanning for the last 12 years now.
And I am Mathieu Desmarais. I'm also a product manager at Creaform. I have been working in 3D scanning for more than 7 years. And during those years, I have been involved in the product lifecycle management, which is the reason why I'm here today to find the best possible way to optimize your product development in order to accelerate your time to market. And to put you into context, as most of you know, over the last few years, manufacturing and engineering professionals have seen their quality standard rise and their needs change. They now work with more complex parts, with more freeform shapes that need to be measured and controlled. The time to perform these measurements and quality controls is also under pressure, and it must be optimized in order to prevent downtime and streamline the development of new products. So one question comes, how can 3D scanning help get through all the product lifecycle management without delay in order to accelerate the time to market? This webinar aims to answer this question and demonstrate how 3D scanning help to overcome major challenges in order to launch a new product more efficiently. To answer this question, let's look at the agenda that we are going to follow today. First, we will review the 4 main phases of product lifecycle management. We will see where 3D scanning can improve and simplify work. We will illustrate the benefits of using 3D scanning with a concrete example in many applications. And then we will show our new products, features, and benefit. So first, I would let Simon start by quickly reviewing the main phases of product lifecycle management.
So thank you, Matthew. Let's take a couple minutes for the basic just to make sure that we are all on the same page. So what does product lifecycle management or PLM means? So by definition, it's just a standard process to organize ideas and guide action used to develop new product. So there's a couple version of PLM, but let's take this simple and general one: concept, design, manufacturing, and servicing. Let's see how 3D scanning can help in each of these steps. So first step, concept. So this is the beginning of the development of a new product. This is where we generate new and crazy concept. Very important steps because you define the requirement and specification of the future product. So designer or engineer would create mock-up or drawing. Typically, they will make iteration until the styling lines and requirements satisfy the development team. At this stage, they mostly validate the look and feel of the product. So during the concept, 3D scanning is very useful to perform the environment and competitive product analysis. It's always a good idea to analyze competitive product and evaluate how they could be improved. So the environment of the object can also be critical if you need mounting point or clearance information, for example. So the information provided by a 3D scanner enables designer to start with reliable measurement that they can trust. With 3D scanning, you can take any physical object and bring it into any CAD environment to help modeling or optimize the concept. This can be really useful to reduce the number of iterations when improving the ergonomic or conception. So once the proof of concept is complete, the next step is the design. So the design phase is where you want to get as close as possible to the real product. It's time for designer to get their first fully functional prototype. With the real prototype in hand, engineer can validate if the engineering is functional, if the components fit and assembled correctly, and if it meets the requirement. It's also during the design that simulations such as finite element analysis, FEA, are performed to optimize the design. As the concept phase, the design phase generally runs in a loop to get better and better product at the end. So during design, 3D scanning is essential to keep the CAD file up to date after making modification on the physical prototype. The 3D scanner can also be used for quickly verification or inspection of the prototype itself. So once complete satisfaction has been reached, it's time to move on to the next phase, the manufacturing. So in manufacturing, this is where units are produced. So at this stage, production create the tooling such as die, mold, fixture, or jig to manufacture the part. Once the tooling is validated and the first article inspection is performed, the quality control will measure, control, and document critical feature to ensure the constant production quality. During manufacturing, 3D scanning is very useful to design suitable tooling. So it allows effective validation of the tooling and can also help to keep the CAD file up to date of those tooling as well. As soon as the first unit is produced, 2D scanning is used to inspect and control the quality of the production by comparing the scan data with the CAD model, so the first design. Since it can be used directly on the production floor, it can detect manufacturing problem quickly. If defects are detected, they can correct the tooling according to the measurement extracted with the scanner. So now we reach the final phase of the PLM, the servicing phase. So servicing, this is where the unit comes to life in hand. So for a mass production that stretch over several years, as you know, tooling equipment may wear. So for instance, it may be needed to document how mold wear out in order to maintain them. In some cases, it will be necessary to repair or replace components to maintain the production quality. So where 3D scanning helps during servicing? So 3D scanning allows engineer to document precisely how the tooling wear and help to make decision to maintain the quality of the production setup. In case of production issue, the scan data will help to determine where to make correction. And finally, if a system is made of whole part that can no longer be found on the market, 3D scanning is actually very useful to scan the last available part or broken part in order to get the dimension, redo the CAD model, and manufacture the part again. So as you know, the challenges that development team faces are important. They must continuously innovate in order to deal with growing competition. So designer or engineer have to deal with more complex part, but still have to deliver product faster than before. So yes, 3D scanning can definitely help them during different tasks, but it's also make the work more endurable and more efficient. So now I want to summarize you graphically the advantages of adding 3D scanning to your actual PLM. Let's take this illustration with only the first three steps, concept, design, and manufacturing, to simplify the example. So as you know, you always start the concept with some input or some information. Then during the following step, designer or engineer will make several iterations to meet the final requirement. Those iterations during each steps will actually slow down the outcome. And with simple inputs, engineer will get simple output as well. So a design that probably every competitor is able to do. So, but when adding 3D scanning as an input, here's the result. It will actually speed up the whole process and reduce the number of iteration. And this is because of 3D scanner gives you a critical information quickly to take clear decision during all different steps of your PLM. and having a better input will give you also a better output as well. So here's the reason why product development professionals need 3D scanning in 2019. So a faster process and a better product at the end that will stand out from the competition.
So thank you, Simon. I will take it from here for the next few slides and illustrate the product lifecycle management with 8 concrete examples in different applications, such as product development and design, reverse engineering, rapid prototyping, inspection and quality control, maintenance and repair. And these applications will take place in different industries, such as automotive, heavy industry, consumer product, manufacturing, aerospace, and power generation. So the first example is about product development and design in the automotive industry. And here is the question to answer. How can we efficiently design parts for automotive aftermarket without access to CAD files? For instance, how can an interior carpet be designed and quickly available for new car models? Well, the challenge here in this product development is the multitude of car brands and models available on the market, which are also renewed every few years. Each car model requires a custom design, and measurements must be taken quickly on complex surfaces. This development must be also done very quickly to be the first on the market. So the solution is to use a portable 3D scanner to quickly capture these complex surfaces within a few minutes. This can be done anywhere as it requires a very limited setup time and acquisition time. There are several benefits to use a 3D scanning technology. First, the acquisition is done quickly. Second, the surfaces are measured completely and there is no missing data, as we can see on the picture on the slide. Missing measurement often cause delays in the product development, especially if you do not have easily access to the car model or the part. The measurements are also more accurate, which will lead to a superior design quality and a perfect fit that will differentiate the part manufacturer from competition. Let's look at our second example, a reverse engineering application in the heavy industry. Now the question we are answering here is how to reduce product development costs with reverse engineering. And let's take the example of a bulldozer where an attachment such as a side boom have to be designed and installed. The main challenge here is not only to take a few measurements on where the attachment will be fixed, but it's to get all the surrounding information to prevent any interference with the attachment, especially with moving parts such as side booms. Without the CAD file available, the surrounding environment is unknown. Another challenge here is to measure accurately spacing or distances between different objects or fixture points. So often direct distance measurement are impossible since there are different components blocking the way. This can lead to inaccurate measurements or a long measurement process if these components have to be removed. So here again, using conventional measurement tool is not an efficient solution. Instead, using 3D scanning will help to gather 3D data of all the surrounding environment, a process that will be otherwise lengthy using traditional measurement tools. This will provide the designer with the position and a high level of detail for every component, whatever their size, geometries, and finishes. So having all the surrounding environment is a huge benefit as it will allow to prevent issues such as interference, as we talked earlier. The accuracy of the 3D scan measurement is also another benefit compared to the traditional measurements. It will ensure a proper fit right away when designing the fixture or other components. And it will eliminate adjustments and iteration in the design process. At the end, 3D scanning technologies will reduce the amount of engineering time spent on completing the project, which enables the manufacturing company to focus more on the part design and also save cost. Our third example, a rapid prototyping application in the consumer product industry. Again, the question now is how to accelerate rapid prototyping and production cycle time with clay models and 3D scanning. So first, when designing a prototype, it is wise to make a first model in order to hold it and try it, as the physical reality is often different from the CAD design. Often designer will make adjustment, change style lines directly on the prototype until the perfect design is found. So the challenge here is how to bring back these modifications back to the CAD model. This can be pretty challenging, especially when dealing with complex parts and small details like on an element. The other challenge is to analyze what the market is already offering to ensure that the forcing design is better. Again, how can this information be brought back to the designers and ultimately optimize the final design? So often clay models are used to design the first prototypes. Designers and engineers then have the flexibility and freedom to play with the prototypes until they achieve the perfect shape. 3D scanning is an efficient solution here as it allows to capture rapidly the clay model and its small details or complex surfaces that can be afterwards easily converted to CAD files. The benefits here are diverse. First, 3D scanning will save a lot of time and accelerate time to market by eliminating the need of long measurement session and modification to CAD file. The computation analysis can also be done quickly by converting the samples to digital models that are available to all designers and engineers anytime and anywhere. Now, our fourth example, a rapid prototyping application in automotive industry. So how can we improve concept car design processes using 3D scan to CAD? Well, the challenge here is a bit similar to the previous example. The first steps of the car design are done on a drawing board, usually, and then the artist continues his work by realizing a clay model that he will refine. But now, again, how does one move from the artistic design to the engineering model or the CAD file at the end? So again, here 3D scanning solution is essential to measure the clay model. The 3D scanner will provide a clean STL mesh, so a clean mesh file that will be ready to be imported into CAD software. And from there, engineers can start building each part according to the model designed by the artist. The benefits here are that with 3D scanning, the path between the clay model and the CAD file is much faster because the measurements and generation of accurate results are accelerated. Then the data transfer and editing are also simplified. Our fifth example is about an inspection and quality control application in the manufacturing industry. How can we accelerate the inspection process in tool design with intermediate quality checks? Well, when designing a tooling, an iterative process of quality control ensures that the part built from the mold or a die, for instance, is built correctly and meets technical requirements. And the challenge here is to speed up this quality control process by reducing the measurement time and limit the number of iterations for adjustment. Traditionally, the inspection process was done using touch probing using CMM. Well, instead, using 3D scanning will help to accelerate the inspection process. Indeed, a 3D scanner can acquire more than 1 million points or measurement points per second compared to just a few with touch probing. So this 3D scanning acquisition speed and data density will allow to create deviation color maps, and these will give a much better visual overview of the deviations and mostly precisely where to make adjustments on the mold or die. At the end, the benefits will be a reduced number of iteration in the quality control process, and it will also reduce bottlenecks created by CMM for touch probing inspection. Our sixth example here is also about inspection and quality control application, but in the aerospace industry. So the question is, how can we develop, manufacture, and inspect a casting of superior quality in less time? Well, here the main challenge when creating a casting is to minimize the amount of material that we are using for two main reasons. First, of course, to avoid wasting material, but mostly to reduce the machining time to remove this extra material. But doing so, how can we ensure that there is enough material before machining and we're making sure that we're not wasting precious and costly machining time? Well, the only solution here is the best solution is to be able to inspect 100% of the surface, and that is the challenge with traditional measurement tools. So touch probing equipment such as CMMs are pretty good to provide highly accurate data of critical parts, but it would take hours to measure 100% of the casting surface. But unlike touch probing, 3D scanning will provide a better solution with an overall 3D deviation color map of the part that will indicate whether or not there is enough material before machining. And all inspection data can be provided quickly and with no delay. So the benefits here using a 3D scanner, well, it will accelerate the casting manufacturing process. A more complete inspection process will allow to identify issues beforehand, and then fix them before they cost more time and money. Let's move to the seventh example. It concerns a maintenance and repair application in the power generation industry. And the question here is, how can we replace headers on a main steam piping system at a power generating facility? Well, replacing these headers in a power generating facility can be challenging. Most of the time, the CAD models are not available, and therefore the engineers have to design the new parts by measuring the actual physical part. And additionally, these headers are often located in very confined or hardly accessible spaces that are only available during a limited power plant shutdowns. So both I would say the on-site measurements and later on the replacement and installation must be done quickly. That's a challenge. So inaccurate or missing measurement will lead to a bad design that can require hours of costly on-site adjustment when installing the new header in the next shutdown. Worse, it could delay the installation if adjustments to be made are too critical. So using a 3D scanner here will solve these issues. First, it will ensure all measurements are taken when the equipment is available. And second, it will ensure that measurements are highly accurate and that the replacement part will fit precisely. At the end, it will accelerate the design and replacement time as well as its cost. And finally, the last example concerns a reverse engineering application in the automotive industry. And this is a pretty neat one. And the question here is, how can we or to participate at the Monaco Grand Prix despite a broken engine 8 weeks before the race? Well, as you might know, the preparation for a car race always requires a series of tests on the engine, and all the components must work at their full potential, since the race would put them to the test. But what one can do when the connecting rods, so the rod that moves the piston up and down, comes out of the engine, of the side of the engine 8 weeks before the race. Well, this is a challenge that one of our clients had to face. He had to repair his engine within a few weeks of the competition, but no all parts could be fitted. Well, thanks to a 3D scanner, the data from the parts to redesign were quickly scanned. The scanner was able to generate a precise mesh that was easily transferred into a CAD file. And 5 days later, 12 pistons went into production and the new parts were ready 3 weeks later. So the benefits here in using 3D scanner, well, it improves the reaction times by allowing accurate measurements to be quickly taken anywhere. And it also allows to send these digital models to anyone and also anywhere to start the design and production process very quickly. This allows to accelerate at the end the design process, and the production of custom part is done at record speed. So that's the end of the example I had to present. I will let Simon continue with the next slides and explain how Creaform new products can help in your product lifecycle management.
So thank you, Matthew, for all those informative case that you just show us. So now let's take a couple minutes to introduce you to our new 3D scanner that we just launched last month. So I will start with the new GoScan Spark, so our fastest and easiest 3D scanning experience. So this scanner has been designed to meet the requirement of engineer or technician working mostly in the concept and design phases. So as you know, most designer or engineer are not expert in 2D scanning, since most of the PLM process is driven in a CAD environment. So this means that 3D scanning needs to be as simple and as fast as possible without compromising the scan quality. They want to get the information, but they want to get it back quickly into something they're comfortable with, so their CAD software. So this is where Creaform can help them with the new GoScan Spark. So with portability, which is already a given for Curiaform since our scanner fit in a suitcase, with the speed, simplicity, and scan quality, they are clearly the main benefits to our product development customer. So now let's take a closer look at those benefits for the GoScan Spark. So first, let's talk about speed. So the GoScan Spark uses 99 scanning wide stripe to acquire the data. It has now 3 times more measurement per second than previous generation with 1.5 million measurement per second. New algorithm in the acquisition software provide a live mesh generation that provide the speed and visualization to help our customer to capture quickly and easily any surface. So speed is not everything. Since our engineers are not expert in 3D scanning, they will need a system that is extremely easy to use. So this is why we added a lot of improvement on the scanner and in the software to get the robust tracking using geometry, texture, or target to provide the best user experience. Just to explain you a little bit more about the tracking. So this is the result of the best and easiest hybrid positioning available on the market. So the GoScan Spark can use geometry and our texture and our target to align all the 3D data together. So it's translate. So if we translate that into the mind of our product development engineer, don't think about how it works. Just go, just scan. So this is a kind of simplicity that they need. So as you can see here on the image, this is the kind of object that can be easily captured with the GoScan depending on your application. So all this without having a quality scan is simply irrelevant to designer and engineer. They need quality inputs. So this is why we changed the camera for 3 high resolution cameras for the geometry and 1 color camera that can create 200 dpi color texture. So yes, with the GoScan Spark, we also capture the texture of the object. So in terms of resolution, the GoScan Spark have 4 times the resolution of previous generation. So in summary, the GoScan Spark provides the speed, the simplicity, and high quality scan for a large range of product development application. So now let me introduce you to the new HandyScan Black. So the reference and portable metrology grade 2D scanning. So a new design with new optics to better meet the requirement of our customer. So the HandyScan has been always the go-to scanner for a lot of situation and for a lot of our customer to solve problem in product development, in quality assurance and production, and even for quality control. So here's the main benefits of the HandyScan Black. So the challenge in developing the reference in portable 3D scanning is right here, delivering a product that can provide all these benefits at the same time. So portability, simplicity, speed, accuracy, scan quality, and versatility. You know, it's not so hard to create a portable 3D scanner that is not accurate or reliable. It's not so hard to create or develop a 3D scanner that will have a good scan quality and a good accuracy, but for a very specific size of part and very specific material. What is hard is when you develop a 3D scanner that can do all of them. And this is what we achieve with the HandyScan Black. So I'm not going to talk about the portability and simplicity of the HandyScan Black since they are a given to me. Portability and simplicity are still the main reason why our customers are purchasing Curiaform device. But during this presentation, I will talk more about the 3 others benefit that have been improved significantly with the HandyScan Black. So the speed, the metrology grade, where we combine the scan quality, the accuracy, and measurement reliability, and the last one, the versatility. So let's start with the speed. So we have now 11 blue laser crosses with a large scanning area. New blue laser technology combined with new optics will allow the system to collect 2.7 times more measurement per second, reaching 1.3 measurement per second. And also the HandyScan Black also have the live mesh generation. So yes, with Curiaform Scanner, we generate STL file right away after scanning. So the output of our scanner are STL file. So now let's talk about the metrology grade 3D scanning. So the accuracy of the Handyscan Black now reach 25 micron. We rely on a German standard VDI VDA 2634 part 3 for acceptance tests, and Creaform is now 17025 accredited for the Handyscan Black. So this ensures full traceability of the system when taking measurement with the Handyscan Black. So with the addition of the new high-resolution cameras, new lens and blue laser, and a completely new surface reconstruction algorithm, the Handyscan Black has 4 times the resolution of the previous generation. So this improvement of the resolution of the Handyscan Black will open new doors to various applications such as small injection plastic, small casting, sheet metal, or 3D print part. Now let's talk about the versatility, a very important differentiator for the Handyscan. So with various features like its new powerful laser, the single laser line, the adaptive scanning area, and limitless scanning value, and even the true portability, it helped to be the best tool for pretty much every part size, for every material and part finish, and for every part complexity. So regarding shiny surface, the Handyscan Black can capture shiny surface such as machine surface or chrome surface. So in summary, one device for a project from a small gear to a full vehicle cabin in and out. So this is the definition of versatility in 3D scanning. And this is the kind of project that can be done with the Handyscan Black. So again, one device from small part to a large object. So in summary, we improved significantly the speed, the metrology grade, and the versatility with the new Handyscan Black. I'm not going to mention the whole feature in this slide. I already talked about it, or improvement mentioned. But it's just more and more in all aspects compared to the previous generation. So our new Handyscan Black is ready to help most demanding manufacturing customer. Just to give you other example, this is just a sample of some of the scan done during the development of the 2 new product. So we tested our new scanner on different parts: casting, stamping, plastic molding, final product. We also tested on different vehicle as well, so helicopter, cars, motorcycle, excavators, snow groomer, and so on. So this is just give you just an example of what we can achieve with our scanner in just a couple of minutes.
All right, thank you, Simon. This completes the webinar. Now, I just want to remind you a few things we have seen in this webinar. First, that the 3D scanning helps manufacturing and engineering professionals to save time while performing measurements and quality control. Also, the 3D scanning figures among the most effective and reliable technology to capture accurate dimensional measurements of physical objects. Also, the time to perform measurements and quality control can be optimized because of 3D scanning. Downtime and installed production can be prevented. And at the end, the time to market of a new product launch on the market can be accelerated because of a 3D scanning. So if you want to know more about our products, I invite you to go on our website at creaform3d.com. And that completes the webinar. Thank you for your attention.
All right, thank you guys for this presentation. And as you say, Matthew, you can go to the website and look for all the marketing materials that you can use. If you have more questions, you can go ask an expert those questions. But we are here right now to actually answer your questions. And before going ahead with the questions, I just want to mention again, this webinar is recorded, so don't worry if you miss something or you want to go ahead and watch more about these new two products that we launched a month ago. So it will be available in the website, also in the resource center, and you will get a email shortly with the link. So I'm going to start with questions here. Thank you all for this is very interesting. I have a couple of here. So the first question. This is a simple one. I think I'm going to start very simple. What's the difference between a red laser and a blue laser?
Okay, I will answer that question. So basically, yes, we change. If you know Creaform in the past, our previous NDScan generation has red laser. So we changed for blue laser, mainly for the resolution improvement that we were looking for. So we are now using the blue laser because blue laser has less speckles, so less noise. So it's create a better well-defined line on raw images. And but now with the new optics, we can see the advantages of the blue laser. So now this is why we are moving to blue laser technology with the HandyScan Black.
Great, thank you. Just give me 1 second. Here's the other one. What is the maximum size of parts that I can scan?
Well, thank you, Stephanie. I'll answer this one. As Simon said earlier, the main benefit of the NDScan and also the GoScan is the versatility, meaning that we can scan from small part to large part, and essentially there is no limitation in size when using our scanners. So as we've seen, we can scan a car, we can scan an helicopter, we can scan pretty much any size.
Great. So how do I convert the STL to a step file?
Okay, I will answer that question. So yes, the output of our scanner is STL file, so it's a surface. And how to convert it to a step file, depending on what's your goal. So there's some function that actually can create a NURB surface directly on tops of the STL, but it will actually fit the NURBs perfectly on the STL. So it will have really low deviation, but it will also keep the defect. As you know, the real object are always, let's say, if you take a diameter or dimension, it's always instead of 10 millimeters, it's going to be 9.9998 millimeters. So by doing this kind of reverse engineering, you will end up with also imperfect dimension. The other way to do reverse engineering is actually to create section, planes, recreate the sketch. So you base your modeling based on the STL. So instead of going from scratch or from nothing or from hand measurement, you have all the measurement on the STL. So you create cross section, you extract dimension. So you extract the 9.991 millimeters, and you type manually the 10 millimeters in your CAD software and do the extrusion and create all those features. So it's typically the process of modeling, but instead of from basic measurement, you modeling in your CAD software using the STL file as a base.
Great. I have here another question. What is your advantage between your 3D scanning to other products in the market?
All right, I'll answer this one. As you have seen, Simon has talked about 6 main benefits that we have at all time using our technology. So that's the difference between our technology. Our technology is very portable as well as accurate, as well as versatile. You'll see on the market scanners that are accurate but not portable. You see scanners that are accurate but the environment around has to be very stable, no vibration and things like that. But with our technology, we have all these 6 main benefits at the same time. It's accurate anywhere, anytime, and it's versatile. You can bring it anywhere, and you can scan different part size as well.
Great. This question goes for you, Simone. The accuracy is the same in the HandyScan Black if you measure a small object or a big object.
Okay, so for a small object, I talk about the 25 micron accuracy. So this is typically for a small object, but if you're scanning a larger object, you're not going to get the same accuracy. So we have a volumetric accuracy equation. So typically you're having it's 20 micron plus 40 micron per meter. So let's say for a car of 3 meters, you will end up approximately with an accuracy of 100 micron. So if this is not accurate enough for your application, we can also combine the HandyScan with a photogrammetry system that will have better volumetric accuracy than the HandyScan.
I'm just taking here a couple of minutes to check your questions, and we are going here with can be scanning during moving parts.
So yes, actually, you can be scanning parts that are moving with our technology because we're using dynamic tracking, using positioning targets for the HandyScan Black, or the geometry using the our target as well with the GoScan Spark. Now the only thing is to make sure that the part is not deforming, so it has to be rigid enough. But there's no problem in just taking the part in your hand and scanning it if it's rigid enough.
I'm going with this question. I love this question. I ask it myself a lot of times. And the HandyScan Black need to use targets or something to detect the shiny materials, casting, or any material.
So yes, the HandyScan Black need to use target for scanning. But either to detect shiny material casting or it doesn't need any setting. So, I mean, we have a shutter time, so you can increase the laser power to capture those shiny surface. But I'm not sure, but if I understand the question, so yes, the HandyScan Black need targets, but in terms of surface finish, we can capture any kind of material.
Thank you, Simone. That was I know it's a great question. It's a simple question, but it's a question that I ask a lot. And here is another one. How does Clafam use 3D scanners in your own product development? What works best?
So yes, we use actually our own 3D scanner to develop our own 3D scanner. So typically we use them mainly when we receive, but for two things, to validate the ergonomy. When we do modification or we play with clean model and so on, and to bring back the information to our CAD software. This is one of the application. The other one is when we receive part from a supplier that are not according to our requirements. So we typically use our scanner to do inspection of those parts and send back the report to our supplier to ask them to make the change and send us the correct parts.
Here is a question for Matthew. And is the HandyScan Black able to rebuild color texture?
The answer to this question is no. The HandyScan Black cannot acquire texture. The GoScan can do it because it has another texture camera on the scanner, but we cannot do it with the HandyScan Black.
Well, this is all for the moment. The remaining questions we are going to answer them via email. So you will have your answers with the product manager here. Simon he's going to send you a short email to answer those questions. So thank you all. See you soon. Bye.